Hey JU students, so for this video what we're going to be doing is we're going to be practicing something from the Chem 204, Gen Chem I class. It's from chapter 3. It's a problem that you guys are going to come across. It's calculating the empirical formula if you're given a bunch of percent by masses, right? So I went and found one from the text. It's 3.48 from the text, number 48. And it says determine the empirical formula for a compound that has by mass 55%, 0.3% potassium, 14% phosphorus, and 30% oxygen, right? So how I would start this one is you assume 100 grams. So then that means that I have 55.3 grams of K. I also have 14.6 grams of phosphorus, and I have 30.1 grams of oxygen. I'm spacing them out because I'm going to have to do three different calculations. So I'm going to move this up here. So what you need to do is have a periodic table handy, and what you're going to do is, so you assume 100 grams, then turn to mole. So we assumed 100 grams, and now I'm going to turn each of these into moles. How do you turn a gram to a mole? Use the molar mass. So I look at a periodic table, and I see that potassium has a molar mass of 39.098. So it's 39.098 grams of K for every 1 mole of K, right? And I put the grams on the bottom because they're going to cancel out with these grams, and I'm left with moles of potassium. We're going to have to do the same for phosphorus and for oxygen. I may not have left myself a lot of room right here, but for phosphorus has a molar mass of 30.974. So 30.974 grams of phosphorus for every 1 mole of phosphorus. And then for oxygen, we all know oxygen, it's 15.999 grams of oxygen for every 1 mole of oxygen. So I'm going to tippy type these numbers out. And they're going to be, I'm not going to abbreviate the numbers, right? So 55.3 divided by 39.098. So 1.414, and we'll go 4. Just don't abbreviate too early, right? 14.6 divided by 30.974, 0.47136, and then lastly 30.1 divided by 15.999. I get 1.8814. Alright, so then what's my next step? So this was my first step. Second step, I turn them all to mole. And my third step, if you remember from class, you divide by the smallest mole. So divide by the smallest mole. So I have 1.4, 0.47, and 1.888. So I'm going to divide everything by 0.47. This will be 1. I'm going to type that one out, right? 1.4144 divided by 0.47136. I get 3.00000, right? So I'm going to show you why I don't assume that this is 3, but it's definitely 3 because it's very close to 3. But it's just good to know that this is the calculated answer when you divide 1.4144 divided by 0.47136. Okay. And then we have 1.8814 divided by 0.47136, and I get 3.991, right? So this is definitely 1. I feel very comfortable calling this 3. And this is 3.99. Remember, these are masses that somebody measured, right? And there's only 3 significant figures. So how accurate are they? They're pretty accurate. So the fact that this is 3.99, I feel comfortable calling this a 4. Right? So then to finally write out my empirical formula, 3 Ks, so K sub 3, 1 P, and 4 oxygens. And that is how you use masses or mass percents to find the empirical formula. Hope this helped out, guys.